Hello, and in this video we're going to be looking at logarithmic properties and how we use those properties to solve equations or simplify logarithms or expand logarithms. Those are the three things we're going to do: expand, simplify, and solve equations or expressions. Now in the last video we did the three properties: inverse, which is how we undo each other because they're inverses. Log and exponential are inverses of one another. We can undo them. That's an inverse property. We went over the exponential one where we can move the exponent from the exponent down in front of the logarithm and make it a multiplication. And we talked about the change of base, and we use that quite a bit to solve. So those three still continue on as properties that we're going to use, and the other two properties we're going to use in the same is the sum and difference property. If we have the logarithm with the same basis and we add two things together, that's the same as one logarithm, not two different logarithms, one logarithm, where we multiply those two values together. So addition means multiplication and subtraction means division. And if we think of exponents, we can think of that as that way too, right? As if we were dividing. This has something similar to this here. If we had a, we look at it in terms of exponents, a to the c power times a to the b power equals a to the c plus b power, because we add the exponents. That's what we're doing here. Logarithms are exponents. We add them together. That's because we're multiplying. That's what we did here. So this would be what we would have here. And then subtraction is division. It's the same property there. So if we were dividing a to the c power divided by a to the b power, that's a to the c minus b. And that's what we're doing here. We're subtracting the exponents and we're getting a division of the two in a logarithm. So these relate to those properties of powers. Okay, so we're going to take a look at how we use these to expand or simplify into a single logarithm. So if we have something like this, we're going to simplify into single ones. If we have something that's complex, we're going to expand it out. So let's do a few examples of that. Let's start with this example here. Log base 3 of 32 minus log base 3 of 4. So to simplify that to one logarithm, that's log base 3 of 32 divided by 4, which is log base 3 of 8. Is there a power of 3 that gives you 8? No, so we can't simplify this anymore. This would be going back 3 to some power equals this number. 3 to the second power is 9, and 3 to the first is 3. 8 is in between that, so it's not going to simplify any more than that. It won't give us a nice number anyway. But we use this property right here. Subtraction is division. Okay, what if we just had a negative sign in front of it? Negative log base 7 of 1 over 6. We had this one right here. Well, this would be the exponent in front. So we're using this property right here. There's a number in front. This is really negative 1 times log base 7 of 1 over 6. So this negative 1 here is an exponent. It's going to be moved up onto the 1 over 6 power. So that negative moves up. This means reciprocal, so this is log base 7 of 6. Base 7 of 6, because that's the reciprocal of that. So that's simplifying that problem. Okay, if we have multiple things here, let's say we have some multiple things here. 3 log of x plus 2 log of x squared. Then we're going to do the same thing as we did here. We had a number in front, so they're going to come up as exponents. So in this problem, the 3 becomes the exponent here. This is log base 10 of x to the third, and this is log base 10 of x squared. So basically we're going to have log of x cubed and log of x to the fourth. Now this plus means we're going to multiply them together. Log base 10 of x to the third times x to the fourth, which would be log base 10 of x to the seventh. We add the exponents. So that would be our solution to that. Okay, we have a couple more examples. Let's move this down. We're not quite ready to solve. A couple more examples I want to use here. All right, so my next example is an expansion example. So we're going to start with something that's expanded out, or that's simplified into one, and we're going to expand it out into multiple ones. So let's try. We'll go with the natural logarithm this time, ln of a to the negative third, b to the second, and c to the negative fourth. And we want to write this as a expansion of logarithms. So we have three things here. We have a multiplication and division. So in this one, if we do the division part first and separate it out, it's going to be this first minus ln of c to the negative fourth power. So we have this. That's what this division does, is subtract. But this one we haven't expanded it out yet either. It's natural log of a to the negative third plus natural log of b to the second. So we can also expand this product out as well into a plus. Now they all have exponents, so those all move it down in front of the logarithms. So we would have negative 3 ln of a plus 2 ln of b plus 4 ln of c. So this would be my expansion of that property. We would expand it out that way. Okay, if we had a square root in the problem, then we just have to make sure that we write it as an exponent. Let's move this down. We'll put one more example, then we'll go to solving. So if we had the example log of 1 divided by the square root of x plus x squared plus or minus 1, x squared minus 1. And we want to expand that out. So it's going to be log of 1 minus log of the square root of x squared minus 1. Okay, so this is actually a number. 10 to some power is 1. This is actually just 0. This value right here is 0. Now I would write this as x squared minus 1 to the 1/2 power. So we would bring this power down in front, so it's negative 1/2 log of x squared minus 1. So this is my solution to that. I've expanded it out, or as much as I can here. We've actually simplified it too by knowing log base 10 of 10 to the 0 power is 1. Okay, log of any base of 1 is always 0, because that's the exponent that you would get to get the answer of 1. 0 to, or anything to the 0 power is 1. So that's how we would use that property. Okay, so solving equations. So when I use this to solve equations now, there are several different types of problems we would run into here. So I'm going to do a couple of different examples. 5 to the 2x plus 3 equals 8 to the 3x minus 1. So let's start with this one. When we have two bases, two exponents, this is a little bit more complex. We can't rewrite it because it's not equal to a number here. It's equal to another exponent. So there's no rewriting this. So what we do on some problem like this is we apply the logarithm to both sides of the equation. So that we can use the base or the exponent rule. So I'm going to take the log of this side, and that should equal taking the log of the other side because they were equal to begin with. So if we take the log of each side, they're still going to be equal. Now that's going to allow me to bring this power down in front of the logarithm. And this is just a number we can get out of our calculator. We couldn't get this number out of a calculator because we don't have a number, but this is just a number here. And we do the same thing on the other side. We bring down that power and multiply by the log of the base, or log of the number. Log base 10 here. Okay, now we're just solving these. We don't have any exponents anymore. We're just trying to find out what x is. So what we need to do here is distribute. I'm not going to use a calculator till the end. So we have 2x times log base, or log 5, plus 3 times log 5. Because that's what I do. I distribute this over that. And I have the same thing on the other side, or similar distributive property, 3x times log 8 minus log 8. Now I want to move all my x's to one side and all my non-x's to the other side so I can solve for x. So I'm going to subtract this 8 over here. So I'm going to get the 2 subtracted. 2x log 5 minus 3x log 8 plus 3 log 5 equals negative log 8. And then I'm going to move this over to this side by subtracting. Okay, so I'm going to get negative log 8 minus 3 log 5 equals these two things. Now I'm trying to solve for x. These both have x's. I'm going to factor that out, take it out of the whole thing. So I'm going to get rid of it in here. So this is going to be 2 log 5 minus 3 log 8. And this is just a number. This is a number. This side is just a number. This is some number times x. So we can divide by that number. We're going to divide by this value and get x equals negative log 8 minus 3 log 5 divided by the whole thing of 2 log 5 minus 3 log 8. Alright, now working that into the calculator is going to be a little bit of a task. So let's see if I can do this. Alright, we're going to have a calculator here. We're going to type this in and see if we can get an answer. Now, since this is a long bar here, we need to put parentheses around the top and the bottom of the thing. So we're going to do that. So here's my negative sign, minus log 8 minus, oops, I need to put a parentheses there because that's what it has there for 8 minus 3 log 5 parentheses, parentheses. So that's the top of the thing. We're going to divide that by the bottom of the thing. We need parentheses around that. 2 log 5 and the parentheses minus 3 log 8 and the parentheses and in the bottom parentheses. So we have bottom parentheses there too. And we're going to push enter. Okay, so I get 2.28. So 2.28778. 2.2878 approximately for the answer. And we could just double check that by putting that in here and seeing if they're close. If I put 2.78 here and 2.78 here, I should get approximately the same number on each side. That would be my check for this. Okay, so that's solving something like that, where we have to simplify both sides that way. Now, if both sides had a natural logarithm in it, it's somewhat easier then, usually. So if we had a similar problem, but we had natural logarithms, 5e to the 2x equals e to the 7x. Okay, so in this kind of thing, we have the same bases, so we can actually divide that out. So this one actually simplifies even easier. We don't have to do all of this logarithm on both sides. We can do that. Let's do the same process. But in this case, we would do the natural logarithm on both sides. So we take the natural logarithm of 5e to the 2x and the natural logarithm of e to the 7x. Well, this is a property. We're doing multiplication here, so that's this one right here. We're multiplying, so that means it's an addition problem. We're going to change that to an addition problem. So this is ln 5 plus ln e to the 2x equals ln of e to the 7x. Now these are inverses. This is the inverse, so this is just 2x. This is the inverse, so this is just 7x. Okay, so we have ln of 5 plus 2x equals 7x. We subtract the 2x, we get 5x equals ln of 5. So the answer is ln of 5 divided by 5. That's the exact answer to that problem. And it was a little bit simpler than the previous one because it allowed us to use the same basis here. In the previous one, we did not have the same basis. We had two different bases. We had base 8 and we had base 5, so it was a little harder. Okay, so if you have two different bases, you have to do it the first way. If you have the same base, you can put them together like this. So it just depends on what you have there. All right, let's try one where we have more expansions. Okay, so if I have this one, log of x plus 5 minus log of x plus 2 equals 2. All right, so if we did this one, we put this together, so it's one logarithm. And since it's minus, it's division. So it's going to be this division problem. Now, we do have one logarithm, one base, one exponent, one number value. So we can convert this one. I can convert because it's in the right form now. Base is 10. 10 here because it's not written, but it is base 10. The exponent is 2. It's right here. The value it equals is x plus 5 over x plus 2. So we're just solving the equation. 100 equals x plus 5 over x plus 2. We multiply by the denominator, x plus 2 on both sides. We get 100x plus 200 equals, this side crosses out here, reduces to 1, so it just gives you x plus 5 there. So we're going to have, subtracting the x, we're going to have 99x equals, subtracting the 200, negative 195. So my answer is negative 195 divided by 99. Now, when we have logarithms, we need to check the answer, because if you put a logarithm of a negative number in there, it's not going to give you the correct answer. So we have to have a number that's greater than negative 2 here, because if I put something bigger than negative 2 here, I'm going to get an impossible answer out of the calculator. So I'm just going to divide this out to see what it is. So if it's, I think, 195 divided by 99 is negative 1.96. So I think that's going to work in the problem if we put that in there, because negative 1.96 is still going to give us a positive answer there. So I think we're okay. So this is my answer. But you always want to try the answer in the problem. Use your calculator, plug it in, see if it works, to make sure it's a no solution. If this didn't work, then it would be no solution. Okay. All right. We'll do one more example with logs in it. Let's do this one. We have log x plus 15 equals log x plus log 15. Okay. Now, this one, we would put these together. A sum is a product, so this side over here is log of x times 15 equals log x plus 15. Since we have logs on both sides, we can just eliminate the logs on both sides and solve without the log. So this is going to be log x plus 15 equals 15x. This part equals this part, because if we take the log of both sides, we should have the same answer. So we're going to have 14x equals 15, so the answer is 15 divided by 14. Now that's positive, so it should be okay in the solution, because that's going to give you a logarithm you can do and a logarithm you can do here as well. So those are some examples of using the properties to solve.